All right, hi there, guys. My name is Wilfred, and I'm a senior math tutor. And today I'll be covering 9 questions related to algebra, functions, and calculus. A little bit backstory upon myself: I graduated McMaster with a major in biochemistry and a minor in mathematics. And if you have any other issues with your math homework or your chemistry homework or any questions related to any kind of concepts related to math or chemistry, just submit them through OneClass and we'll get to them as soon as possible. But other than that, let's jump right into it. Okay, so the first question reads, using the arc length formula, find the length of the curve y equals 2x minus 5 in the interval of -1 to 3. And then check your answer by noting that the curve is a line segment and calculating its length by distance formula. So the first thing is that we have our function here, which is y equals 2x minus 5. So we do note that this is a linear equation. So this refers to a line on a graph. And that means that we can use the distance formula to calculate the distance of this line in the interval of -1 to 3. Okay? And it's a closed interval. So the distance formula that we are using is d equals basically x2 squared, sorry, y2 squared minus y1 squared. Okay. So this formula is x2 minus x1 squared plus y2 minus y1 squared. Okay. So that's the distance formula. And using the arc length formula, gives us the length of a curve by calculating the definite integral from 3 to 1 of the square root of 1 plus the derivative of our function squared. Okay, so we're going to use the arc length formula and the distance formula to calculate the length of the curve, and if these two are right, then we can verify that the arc length formula is indeed working or is correct. Okay, so the first thing that we want to do here is to find the derivative of our function, which is our curve, which is 2x minus 5. So dy over dx is basically 2, right? Because the derivative of 2x is 2. All right. So now using the arc length formula, we'll label it L, and I'll put L here too, just not to make it confusing. Okay. So the length is equal to the definite integral of the square root of 1 plus the derivative of our function squared. Okay. So in this case, our derivative of our function is 2. So 1 plus 2 squared dx. And that's equal to, it's 3 negative 1, my bad. And that's equal to the root of 5x from 3 to -1. So calculating that, we get the root of 5 times 3 minus negative root 5, which equals 4 times root 5. Okay? So that's using the arc length formula. All right. Now we're going to use the distance formula, which states that the x2 minus x1 squared plus y2 minus y1. So we have to find y2 and x2 first, and y1 and x1, okay? So first we're going to need to find, so if we use the second method here, we're going to need to find x1 and y1. So x1 is -1, and y1 is going to equal 2 times -1 minus 5, okay? And that is equal to -7, right? So that means x1, y1 is equal to -1, -7. And x2, y2 is going to be, so x2 is equal to 3, and y2 is equal to 2 times 3 minus 5, and that's equal to 1. So x2, y2 is 3 and 1. And now using the distance formula here, we have d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so if you equate these together, we get 3 minus 1 squared plus 1 minus 7 squared, and that's all square rooted here. Okay, let me just move this square to the other side. All right, and if we calculate that, what do we get here? We get 4 squared plus 8 squared square root. That's equal to the root of 80, and its radical form is basically 4 root 5. Okay, so the distance formula for our length of our curve here is the same as using the arc length formula, which gave us the same answer. So that means that the given curve is a straight line and its length is 4 root 5. So 2 more important things to note. When you're calculating the arc length of a curve, you need to make sure that you have a definite boundary for your curve. So here we have -1 to 3. And the other thing is that you need to make sure that your derivative is continuous and that it exists. If your derivative doesn't exist at that point, then you can't calculate the arc length of your curve. But other than that, the solution is correct, and we can move on. Cool. All right.